A ratio is a fraction. We need to make sure we got the terminology now, but that's all it is. Hey, 3/4 of the time I order steak, 2/5 of the time I go to a restaurant, I order dessert. They're fractions, they're ratios. They're also rates of change. But here's a big idea. If you have equal ratios, they are proportions, or they're said to be in proportion. So this fraction is equal to that fraction, and because of that, we should be able to cross multiply and know that the results are the same. 2 times 9 is 18, and 3 times 6 is also 18. So any two fractions that are in proportion have this characteristic. Their cross product, because product is what you get when you multiply, their cross products are going to be equal. Now remember this, because in math we have cross canceling, cross products, cross multiplication. You need to know what's what and when to apply each thing. Alright, these two fractions are equal to each other, so because of that, if you cross multiply, see what happens. What's 3 times 20? Well, that's 60. What's 4 times 15? That's also 60. So any two fractions that are in proportion, when you cross multiply, you get equal values. But consider this, these are not equal fractions. So let's see what happens when we cross multiply. 2 times 4 is 8. 5 times 3 is 15. So their cross products are also not equal to each other. So if we get to a situation where we are shown this equation, you know that this fraction is equal to that fraction, the way to solve it is to employ the notion that any two fractions that are equal, when you cross multiply and get 12x, it has to equal what you get when you cross multiply the other way, which is 48. And now it's a simple one-step equation, divide by 12, and you know that x is 4. You can always double check your work, put 4 back in there, and you'll see that it does work. Go over here, same thing. Two fractions are equal, they're in proportion. So it must be true that you can cross multiply and know that the results that you get have to be equal, because that's what happens when you have fractions in proportion. So this would equal 100, divide both sides by 10, x must be 10. 4/10 will simplify down to 2/5, and 10/25 will also simplify down to 2/5. The two fractions are equal, their cross products are equal. Same thing here. Now you got to be careful with this. There's a big mistake that can happen, and let me show you. Equal fractions in proportion. When you cross multiply, you must get equal products, but be careful. This whole value is one number, it's one quantity. So that whole quantity, that whole number is a package deal, must get multiplied by the 12. We know what to do when that's the case. We take 12 and multiply it by the quantity, make sure you use the distributive property. And then this way, 9 times 8 is 72, and you know how to solve those equations once you get there. That's how you're going to figure out what x is. Now rates, here we go. Rates are slopes. So let's do this. When it comes to learning things, you want to compartmentalize wisely. You want to chunk ideas together and have the fewest chunks going on in your brain as possible so that you can learn the greatest capacity and tie things together. I would argue that you should be chunking rates together with slopes. They're the same thing. The further you get into math and calculus, slopes are rates, so you want to see it that way. And we know that slopes are a change in y over a change in x. So keeping that in mind, if a person earns $30 in 5 hours, that's a rate of change. That is a slope. Consider this y, and that's x. So it's, rate of change. Change in y, we're gaining $30 as we go over 5 hours. So it's just like slope. Now, let's make another slope, another rate of change out of the second piece of information. How many hours will it take to earn $48? Well, we don't know what the number of hours would be. Since we decided hours would be x and dollars would be y, we're going to make hours be x right here. And so we're going to set this, they have to be equal rates, equal slopes. So this ratio or rate must be equal to $48 divided by the unknown number of hours that we're trying to find. So slope equals slope, rate equals rate, fraction equals fraction, ratio equals ratio, and they must be in proportion because they're equal to each other. So now we just bust out that idea that when you cross multiply, you get equal amounts. 30x is equal to 5 times 48, which is 240. And if we divide both sides by 30, we get that x is 8. If you work 8 hours, you're going to make $48. All right, unit pricing. This is another rate of change, another slope, another rate of change. A box of cereal, 12 ounces, costs $2.40. What is the unit price? The unit price means we're dealing with how much does that unit cost? How much is 1 ounce of cereal going to cost? So we're asking 1 ounce of cereal costs how much money? So we're usually going to put dollars over the unit. And so here's what we have. It cost us $2.40 to purchase 12 ounces. So that was our rate of change that we're given. What's the unit price? We want to know how much dollars, what's the unit price per 1 ounce of cereal. So that's our proportion, because these unit prices, these rates of cost per ounce of cereal must be the same. And again, once you set up that proportion, you cross multiply and you got it made. 12x must equal 240 times 1, so 240, and we divide this by 12, we divide this by 12, we get that x is 0.2. X is $0.2, which is the same as 20 cents an ounce. So we would say the final cost is 20 cents per 1 ounce. If you go to the store, you'll see those unit prices listed in fine print next to the $2.40 for the whole box of cereal. So it's the cost per unit, per ounce, or per pound, or per whatever. Okay, now, everyone knows that if you buy in bulk at a big store that sells big honking packages of stuff, that you'll save money. Wrong. And that's how those big companies, those big grocery warehouses make their money. The people that don't understand numbers very well, they don't understand that sometimes the big packages have a higher unit price, a higher rate of cost per 1 ounce. So for example, we just saw that a 12-ounce box that costs $2.40 has a unit price of 20 cents per ounce. Now you go to those big stores and you buy a 30-ounce box of cereal for $6.60. Hey, because it was a bigger box, we must be saving money. Toss it in the cart, let's go check out. But hold the phone. The unit cost over here, well, let's see. It costs $6.60 per 30 ounces. That's a slope. That's a rate of change. So we want to see, well, if that rate stays the same, what would be an equivalent rate per 1 ounce of cereal? And we could use another variable. In fact, maybe y makes all the sense in the world because it's change in y over change in x. So let's use y. We want to know the unit price per ounce. So we have our proportion, we have our two rates. So we're going to cross multiply. 30 ounces times y is equal to 660 times 1 ounce. So we get this right here. I'm leaving off the units for now. We probably shouldn't do that. At any rate, we got 30. Divide by 30, that's 0.22. So y is equal to $0.22, which is 22 cents. So we just found that our unit price for the big box is 22 cents per ounce. That manufacturer did not have to spend more money producing that. They got greedy, and they will rip you off. You want to look at unit prices in the store to see if it really is better to buy the bigger box. Now, usually it is, but it's not always the case, and it cracks me up when I go to those stores and just do the unit prices in my head to see in which cases they're ripping people off and which are they doing okay. So any fraction or ratio that's in proportion will yield an equal cross product. And I will leave you with this problem right here. What if you had 28 divided by x is equal to 7? Now, we're not sure exactly necessarily how to do this problem. How do you undo division by x? But here's a suggestion. Do you remember how you can always make a whole number into a fraction by putting it over 1? Well, looky there. Look what we just made. We just made a proportion of two fractions that are equal to each other. So you're going to find that the easiest way to solve that problem is to put it over 1 and say now, because they're two fractions that are in proportion, we can cross multiply and know that the results must be equal. That's an easy equation to solve. Divide by 7, x equals 4. Proportions, ratios, rates of change.